Welcome to the Post-Tension Parking Structures webinar series, proudly presented by the Post-Tensioning Institute. This series is dedicated to showcasing the advantages and benefits of post-tension parking structures. This four-part series, moderated by PTI's Executive Vice President Tim Crystal, brings together a panel of industry leaders, including Asit Boxy, Michael Pedraza, Tom Pfeiffer, and David Wolkin. Throughout this series, we will deliver practical insights and technical knowledge to empower industry professionals in choosing post-tension concrete as the preferred option for parking structures. Covered topics include functional advantages and benefits, cost-effective design and construction features, sustainability and resilience advantages, and long-term durability case studies. By joining us, you gain access to thought leadership and a comprehensive understanding of how post-tensioning can enhance parking structure design and performance. Let's join in on the conversation.
All right, so welcome to our second episode in our webinar series. This series, of course, is discussing cast-in-place post-tension parking structures and all of the inherent advantages that they entail. We've got a four-part series. This is episode 2. And today we're going to be focusing on specifically the advantages and benefits from a cost-effective standpoint and schedule standpoint, both design and construction of cast-in-place post-tension parking structures. So that's our focus in this second episode. We have our panel of experts here again today to have this discussion. And so ultimately the intent today is just to kind of delve into the detailed points of what inherent advantages PT has over other possible solutions, and then talk about some very specific items that are kind of more of a guidance and direction related to design tactics and strategies, and like I say, construction do's and don'ts, things like that really improve cost effectiveness overall. So kicking things off, kind of just want to open the floor here to the panel to discuss just general things in general that are inherently very cost effective from a first cost standpoint of cast-in-place post-tension parking structures.
I can take a first stab. Being on the construction side of things, I think the cost effectiveness, design is one aspect of it, the construction is the other. And for us, one of the things that we talk about with engineers is repetition. Help me with bay sizes that are repetitive, beam depths that are repetitive, if so, heights that are shorter or at least the same from floor to floor. That way we can reuse formwork. And as guys learn, you always hear about a learning curve, and if we can knock that out early, and then the team is repeating that over and over again, we start picking up production, and that can lower the cost on the construction side, which is a big part of cast in place. So it's a lot more. There's a lot of other things that can go into that one. Maybe we can talk through here, but I know repetition off the bat is one. Another one is concrete strengths. Puddling is just one that we've run across here recently. It's definitely not cost effective for us. I get that from a design standpoint, maybe needing higher strength columns versus what you have in the slab, but based on the ACI guidelines, if you have to try to puddle the concrete around that, that's very expensive for us. So a lot of times we'll end up just increasing the slab mix, which can add cost for, there's got to be a equilibrium there that we can walk that line.
Before you talk about the economics of post-tensioning in general or post-tension garages, what I love about post-tensioning and its application for post-tension garages is how versatile post-tensioning is. It is the best use of high-strength concrete and high-strength pre-stressing steel compared to all other structural systems. And the advantage of cast-in-place post-tension members, especially a PT garage, is the continuity that you can use. You can use post-tensioning in the most ideal manner. You take advantage of the continuity that you can achieve in a post-tension garage using post-tensioning just cannot get from another alternate structural system. And it allows you to balance the loads as you need it. And that results in the thinnest slabs you can get and the most economical depths of the beams. And to me, that provides huge economies in terms of the least amount of material you need to resist the loads on the structure. That will then lead to reduced material for foundation design and also for your lateral load design. So you just cannot beat that combination and with other structural systems. So that to me is the most fun in terms of using post-tensioning for as a structural system for designing parking garages. And then if you want to take it a step further, architectural challenges that you have, you can do a lot with post-tensioning compared to other systems in terms of being able to design very unique architectural features and framing that you may be faced with on a given project. I mean, a lot of the structures are rectangular, but when you have oddball shapes like circular ramps on parking garages, helical structures for ramps on a garages, which are very common and mostly in for airports. I mean, that's something you can use post-tensioning for. So there's a lot of versatility and flexibility that you can achieve by using post-tensioning.
For us, we're in a market where we do a lot of one-way slab type construction. So it's beams and girders and slabs, right? And for us, that, I mean, the biggest advantage, especially when it comes to parking structures, which we're all talking about, is long span construction. We want the biggest open areas in the garage we get. To do that, long span's the way to go. And so by using the post-tensioning materials, we can make spans bigger than what you would normally do in like reinforced concrete construction. And we can economize the size of those members too. And not only are we getting the cost savings from the reduced member sizes, but you're also getting the added serviceability of having the post-tension in it for deflections and vibration control and those kinds of things. And it may seem like simple, okay, well, we just have a longer beam. Well, longer beams mean typically fewer columns and fewer footings. And so we can, even if we had a comparable beam size to say standard reinforced concrete construction, let's say we've got the same size of that, we're going longer lengths, so our spans increases, so we're still reducing all the other relative costs for columns and footings. And kind of to piggyback on what Asit was talking about with that kind of construction nuances of having odd shapes or other things, and we do cantilevers pretty easily with PT beams and girders. And the nice thing is with post-tensioning, you can play with the profile to get added benefits. So we can get rid of certain deflections just by messing around with the profile or modifying the profile along its length to get more benefit out of it than say what a standard reinforcing bar could do. The other thing we like about it when you're talking about monolithic type construction is the redundancy of that system. And I think as opposed to other systems, there's a certain level of redundancy that we appreciate out of post-tension, out of monolithic construction, but particularly post-tension construction, because there's a lot of additional, I'd say, kind of belt suspenders with that system that you get for minimal cost.
One of the things I'd like to note about post-tensioning and post-tension cast-in-place parking structure is on the construction side and the scheduling side is we've had a lot of fast-track projects, and with those in those cases, sometimes certain types of systems you may have to wait 6 months or a year to start construction on them. But with post-tensioning, it's really quick for them to to get the material and to get it out on site and start working. So if you have a fast track project, I like to go there, especially on a tight site, hard conditions to work in. You're not bringing in big cranes or anything like that if you don't need them. So that's a very helpful thing in the construction scheduling side.
And I think, it's interesting to tie all that together. The flexibility of the architectural stuff that Asit talked about. I mean, if you're cautious with the rest of the design, some slight architectural features don't really add that much cost. So you get a lot more flexibility, for lack of a better term, with minimal cost impact, which that's kind of hard to believe. But if you kind of follow, through PTI, we're going to put out a guideline that help with cast in place construction and design, how to make it more cost effective. And some of the things we talk about in there are the repetition I mentioned before. But if you're following those guidelines from the construction standpoint, having that flexibility to make a cantilever around the edge doesn't add cost like people believe it does. And to your point, David, on the long spans, part of that Techno did a cost study, and what we found is that for each, we tested 60-foot spans, 62-foot spans, and then two-way flat slabs, and we found in each one of those that 60, 62, and a flat span that the other direction, if you had 20-foot spacing, that was kind of the most cost effective, from a relative standpoint. So there's always things you can do, but you can get very, very cost effective with cast in place post tensioning to compete with any other structures. Just keeping in mind and being flexible with how you design it, and what you do in that time frame.
One of the things to add to what everybody has said so far is you can design the post-tensioning, basically the load balancing, to accommodate different stress levels. Meaning, if you need your garage to perform for a longer duration, say, you can say, okay, I'm going to add more pre-compression to the members in both directions, which will reduce the overall stresses on the member. If you want a more aggressive design, you can make the garage work harder by playing with the stress levels, and which will probably give, and not probably, it will give you more economy in terms of reduced amount of post tensioning and rebar. So at the end of the day, you're load balancing in a manner that can result in more effective and a more efficient design. And that is something you can achieve with post-tensioning fairly easily.
See, that's a great point. I was thinking about what Michael was talking about earlier about trying to standardize member sizes on a structure, for efficiency. Adding the PT to that beam, that gives us another tool to do that. Whereas you might be locked into trying to increase a member size in some cases. With the PT, we can vary that how we need to get the member to work or perform the way that we want to. And most often we can get, a typical member size to cover 80% of the design just by modifying the post tensioning in the member.
For designers, that's a very good point, David, that you not only have the ability to repeat a certain design over from a construction point of view and from a design point of view, but if you can design the 80 or 90% that is repeating all the time for an optimal situation where you want it to have good performance but still be very, very economical, then you can take advantage of that, not only from design, but also from a construction perspective. And then in the the non-typical areas, you can design it accordingly. That way, you achieve the desired results. So I think that's something that young designers should be always constantly thinking of doing when they design these garages.
On that note, Asid, I would add, like, there's some detailing things. I guess I would just say for designers to be open-minded that, kind of a low-hanging fruit one is, a closed tie in a beam versus a U-bar with a cap. It seems pretty obvious to people who've done it for a long time that if you have a closed tie in a beam and you build that beam, you've got to thread the PT through it as you go. But today it's more common to see a cap bar where you just have a U, so you can put the PT in and you put the cap bar over. But there are a couple of other detailing things that the guys in the field have done it a long time, and if there are some, if the designer can be open-minded and work with them and say, hey, look, here's a solution that helps me reduce congestion in a beam column intersection so that I can get the PT where it needs to go. Does that work for you? I think being flexible and open-minded on some of those things will really help drive the cost effectiveness of a structure.
Just to point out, I mean, some of the things that while you're talking about details and stuff like that, is the PTI manual has some typical details in it that I think it's important for people to look at. And then also the Parking Structure Committee, DC 25, is coming out with a new guide here shortly that will have a bunch of typical details and things that will go along with parking structure. So those are two things to look for. Look for at PTI with the manual available right now that you can go out and look at. And if you don't have a lot of experience, or if you just want to brush up on what the latest details are, that's definitely something to go take a look at, read on, and it'll give you some more thought into this.
Yeah, I was going to add, Tom, that the PTI has a library of details on for cast-in-place post-tension structures. I know we're updating the current parking garage manual, but even the PT manual has a chapter on parking structures and has a lot of, and the design construction chapter also has a lot of standard details that can be used for folks who are just getting started on using post-tensioning. So that's a very good resource.
Guys, maybe expand upon something that some people overlook sometimes about the regionality of things. If you're designing across the U.S., I mean, what a contractor and a formwork sub will do in North Carolina and Georgia is not necessarily what happens in Texas or California or Illinois, and how important it is to really, in a schematic phase and pre-planning phase before you even start designing, to understand the standard beam forms, standard beam sizes, column forms, things like that. Because again, that's where you're working as a partnership with the construction side before you get into all the nooks and crannies of design. And so maybe elaborate on that, because again, it's not a one size fits all US solution. It's certainly major impact on economics from a regional standpoint.
I think the first thing that comes to mind, two sides of admixtures. That seems to be the thing that I'm in the Carolinas and work mostly in the East and in the South, all the way over to Texas. And there's not a whole lot of snow in this area, but we do see a lot of admixtures that can increase the cost unnecessarily. And it's just a regional thing for people from the North who are used to, maybe some more intense snow with salt implications in the concrete. We don't see that down here necessarily. So it's just something to know. There are formwork systems across the country that vary. There's some that are used a lot more out west now that are, maybe owned by some of the people, some of the contractors out there that you don't see as much in the East. So yeah, I mean, and those things can make a difference. Some of the pricing that we did in that tech node to kind of narrow it down to the most cost-effective layout, let's say, we are not assuming anybody's owning formwork systems. So different formwork systems and how they affect the construction cycle time can be, improve or slow down the construction. But that could be not just regionally, but that could be from contractor to contractor. Certain people own equipment, they may be very familiar with it. The next guy may not, and can be just as cost effective with a different system.
That's an interesting thing that you said. I know that on a lot of long span garages, at least in the market that I'm in, which is in the Texas area and the South, generally in the South, if we have or if it has been determined that we're going with a cast in place long span system, my first question to the owner slash contractor is, hey, what formwork system are you going to use? Do you like certain contractors in especially in the Dallas area, they prefer 18-inch wide beams. It's just that's something that just they have been used. So we'll get that information from them, and if it's possible to incorporate that in our design, and that way we're designing our project for the formwork system that they have, and makes sometimes that can make a huge difference in the cost. So that is something that should be a question asked, for any structural firm that they have determined that that's the decision that they are going to, use a long span system. It would be a prudent thing to ask, what's the typical formwork system available, and then try to incorporate that in your design. That way you can get a more efficient design. So
I'll add to that. I mean, I think it's kind of a double-edged sword. You hear people say that they would love to have the design more complete when they bid it, but to your point, a seat, I mean, there's a lot of advantages to getting input and commitments from the construction side to kind of have that. I don't want to use the word design build, but that design influence from the constructability standpoint, because there are a lot of ways that you can cut cost just with having that. Hey, I'm going to be the one building it. I'm going to be using this formwork system. To your point, there may be other things that contractors see that, it's just a little tweak to the design, or may not be a tweak to the design at all, but it's easier on the construction side that can really help with the cost effectiveness of that parking garage.
The more you know up front always helps a project. And I mean, we see that a lot with contractors getting involved early on, whether it be a turnkey concrete contractor or subcontractor, or even a main GC that self-performs. If they're on early, they can help you select those formwork systems. They can help tell you what's going to drive the cost, because let's face it, right now labor is a big part of cost of these structures, and the more you can help them, it'll help yourself. And having a somebody to talk to early on definitely helps that. So we always encourage owners to help get involved. And a lot of times it points to, they'll talk about different systems. It'll point back to post-tension system as what they want to use, and then just how do we incorporate that the best way to make this an economical structure.
When you were talking about the tight job sites and things like that, considering the formworks, scheduling, some of the formwork systems are very crane intensive, others are not. So, it depends on the job site, the work hours. There are places where you can only work between certain work hours. And so it could be beneficial to, make something a little bit more modular, panelized, so that you could move it quickly and be a little bit quieter, more effective. So there's lots of things that you could go into. We'd be here for a long time if we went into all of them, but I do think the conversation with the construction team early on definitely will help drive that cost down.
To add to that conversation about tight sites and crane logistics, I know in one of my experiences I've had in my career working for a concrete subcontractor is we did a parking structure vertical expansion, and it was a hospital garage. It was a very intense site and lots of operational constraints and things about not shutting this and that down and keeping everything functioning, and even just some cool alternatives where you can come up with strategies to what I call walk the forms up the deck and build a garage within itself. You're not going to have a tower crane. You're not going to have crawler cranes. You're not going to be doing some of the things that are maybe more conventional on other job sites or other new builds. But whether it's a new build or a vertical expansion, it's things that you can do a lot of times with cast in place PT that are very advantageous from a scheduling standpoint and from a safety standpoint and from an operational standpoint as well, that are tied into that construction technique. And just like Tom talked about earlier, the tight sites, there's little postage stamp sites you get in an urban environment sometimes where you've got nothing else you can do except for cast and place PT, and it performs beautifully because you're economical in your framing, but you're also very economical and schedule driven on your construction side.
To Tom's point about coordination, another thing that I've seen, which has really helped the contractor and the owner, is the earlier in the project you bring all the teams together, you can almost design the garage to sort of match with the construction schedule in a manner that will make the construction of the garage a lot faster, by coordinating and designing so that you pour concrete, you stress, you drop the forms, and knowing where the construction joints are going to be and coordinating that information with the structural engineer. Sometimes you can save several weeks in construction time, just with that coordination, rather than just sending a set of drawings out, letting the GC and the contractor figure out, scratching their heads trying to figure out, okay, well, how are we going to build this? But if you discuss it up front, then you can really save a lot of construction time, and which is money at the end of the day. So.
I've had some really tight urban sites where you've had like a high rise that's maybe next to a really small parking deck. And the great thing about PT and a cast in place deck in some of those cases is you'll get the contractor that pretty late in the game, they'll be like, hey, we want to use the top level of the deck for a laydown area because we have nowhere else to go. And there's just this type of system. It's very accommodating. You make some small changes in the PT. Maybe you have to slightly deepen a member or two to give them some capacity, but it's very, very little change. They can keep the forming system the same, and they can still, maybe use the top part of the deck for a laydown area during the construction activities. Or as we've said before, if that's a terrace or some sort of pool terrace or all that, again, you have a lot of flexibility in this type of system that when you get in these tight urban sites or these mixed use sites where they're trying to do 10 different things on a site, this is just one of those materials and types of structures that we kind of always go to for that.
I don't know that I can call myself a contractor if I didn't bring this part up, but just, piggybacking off of the, communication standpoint of this, upfront is great. Tom, what you mentioned about working with a contractor to help them be more efficient. I have to bring up, just the responsiveness to elongation reports and approval of those. That's kind of a sticky subject, but making sure, because that can stop a job and can slow things down. So that communication and open communication between the engineer, the GC, the contractor, because that's how you cycle your formwork. And you talk about repetition, you're cycling formwork, but schedule, as any contractor would tell you, schedule is money. So if you can continue to move your formwork because you're getting things poured, stressed, and approved so that you can strip and move forward, that's a big deal. So that communication plays a big part across the whole gambit, and it goes both ways. Contractors got to be willing to talk to.
Yeah, Michael, I learned early on in my design career that, that's super important to a contractor, and just teaming with the whole team, right? If a project's not successful, then and the owner's not happy, then it's looked down upon the whole team. But early on, it's like you look out on a construction site on a daily basis, and they may have 100+ guys out there working, and if they're stopped for a couple hours waiting for something, it's a big deal. So. Yeah, I mean, it's really important that, everybody works together, but you also understand how things are driven and what those drivers are and how you can accommodate them, whether it be during design as an engineer or during construction. Because again, working as a team, it just works out the best. I mean, everybody helps everybody. If there's ever an issue, one way or another, if you're more helpful, it's easier to resolve. But post-tensioning, really though, if you get into a sequence of it and you know when it's coming, you know how it is. I mean, it doesn't take long to check those reports. and keep everybody moving, and the system just works great. And with the high early strengths and stressing quickly, I mean, the flips and the turns on those formwork systems are just super fast, and that helps the schedule too. So
We insist on a pre-con meeting on every job. Before you start everything, you have the testing lab, you have the PT supplier, you have the GC, maybe the owner, architect. Everybody needs to be on the same page. And I think having a pre-con meeting is extremely important, and it'll let the job move because you're not only talking about the concrete cylinders and testing, but you're also talking about the lab being present during stressing, turnaround times for elongation reports, expectations, when will the engineer record get released, allow the contractor to strip forms. All of that is all discussed in that pre-con meeting, and to me that it is jobs where we have the pre-con meeting, they go very smoothly, and the ones that for some reason don't, then you start having issues. So I think that's really important. So
one thing that people don't really often think of is about volume changes in concrete. And to kind of talk about this in terms of sequencing and figuring out where your construction joints are. I mean, because of the PT, we can get some pre-compression in the slab pretty early. And quite often, we're only limited to pore size based on how much concrete the contractor can place in a single lift, or whatever you want to call it. So we can go 300 feet in one direction and 200 feet in the other. Typically it's, I don't know, 18,000 square feet, 400 cubic yards, something like that in a pour, maybe 600 cubic yards. But we have some flexibility to make those pore sizes whatever they kind of need to be, versus saying, well, we're only going to make it this big because, there could be some concerns about early shrinkage and cracking, but we don't have to deal with that, So from Mike's standpoint, when he's thinking about laying out, because quite often we don't even know who the contractor is we don't know who's going to build this, right? We don't know what forming system is being selected. We just don't know. We have an idea in our markets, whether we're Midwest or East Coast or whatever. We have some ideas, but we're just trying to kind of design the most efficient structure we can to the most common form sizes. And more often than not, the pore sequence that we come up with is what gets used in a project. They might tweak a joint, a bay or two or something like that, but generally, to be able to get as much material placed in at one point is typically the most beneficial, because as long as they have enough formwork, they're only moving it X number of times, and sometimes we've hedged one way versus the other. They want to go bigger because they only want to move it, fewer times, because it's all about turning that formwork over, right? So how long does it take to get this section built? And then how quickly can we turn it over? And we kind of have a good feel of that, but going back, if there's, it's a kind of beating a dead horse, but being able to have a GC on board who knows the business and knows what they're doing, that's huge. Because it saves the whole project. It saves us as designers, because we don't have to go back and redesign anything. And it makes the owner happy, because every time a change comes, that you're putting the owner through a process that it's just maybe uncomfortable.
David, I think those are great points. It's thinking through some of that is, you guys are pretty sophisticated engineers, and I mean, it's as simple as thinking through stressing lengths, and stressing access. Those things are not always done. A lot of people who are familiar and very familiar with PT, but if you can do that at the design phase and think through, and from a contractor's perspective, whether you know who they are or not, then when your drawings get priced, if you don't have to make special accommodations for, oh man, I really got to think through how I'm going to stress this, whether it's too long of a cable or I just don't have access. Prices go up when those types of things, when questions are brought in. So making sure you've got stressing access, and making sure that anything that's unique is very clearly noted on the drawings. It's all that will do. The more information you can get out there at design time will help lower that cost as a contractor's bidding it and making sure that they're meeting the intent of the designer.
David, you talked about volume change. So many times you have parking garages that are fairly long. I mean, you have 300-foot, 350-foot garages, and invariably, I mean, in most instances, you're going to put an expansion joint or a pour strip. So in those instances, of course, at the design stage, you have to think about, if you have an expansion joint, you cannot show a stressing arrow on one side or stressing arrows on both sides. You gotta think about how the garage is going to be built. So in those instances, you have to show the pour sequence on the drawings, and that's something that we do. And it also allows the contractor to bid on the job too, so because they know, they sort of have an idea about how it's going to be built, and you can always tweak it a little bit, but it is important to show that information on the drawings too in those instances.
It's one of the first things we do. It's probably step 2 is we try to figure out how somebody's going to want to build this garage. What side of the site do they want to start on? Where do they want to end up? How are they going to get their formwork across the site? And then we start thinking about, okay, what direction of PT stressing and where could there not be access and this and that. And I think there's this kind of, unfortunately, I think there's this kind of like stigma against how difficult PT is. It's not. It's a nuance to the design like any other design, steel, wood, anything. And yeah, there's some nuances, but it's not difficult. And the benefits are, I would say, I don't even say outweigh the design nebulosity of it. It's not any more difficult than any other method of design. And so, when people talk about, well, stressing access and this and that, it's really not a difficult thing. And if you have just a little bit of experience with it, it's not hard. It's a facet of design that you have to consider. And once you've done it once or twice, it starts to become second nature. And it's not anything I think anybody should shy away from just because it's this added material or it's something that you have to kind of wrap your head around. But and there's all kinds of ways that you can manage these with pour strips. You're thinking about sequencing, and a lot of it, as our discussion about sequencing is just thinking about how it's going to get built. And if you're in a part of your career where that's a little bit nebulous to you, talk to somebody who's done it. Talk to a contractor, talk to coworkers, talk to a supplier. There's so many people out there who would be willing to help you through these design facets to get to a really good solution.
And I'll add to that too. I think you hit the nail on the head with a lot of things. We prefer, as a concrete contractor, we prefer PT decks. There's just a lot of benefit for us. I mean, we've built enough of them. We're very familiar with them. And to your point, it's not rocket science at the end of the day. It's interesting. When I was a PT supplier at one point in my life too, and I started realizing that the biggest issue on the East Coast, at least, was there wasn't a level of experience with PT. People thought it was new, and that was one of the first. I gave a talk, still do, at NC State, just to get rid of that myth. I mean, it's don't hold me to the timeframes, but I mean, we're approaching 100 years of building structures in the U.S. If I remember correctly from that lecture, that one of the first structures here was built in like 1930 something, 1940, somewhere around there. And there may be some primitive stuff before that, but you really think about that, and it's not new. It's not new in any part of our country, and it's really just the lack of understanding. And once you start dealing with it and looking at it, it's very cost effective. It's very construction friendly. There's lots of and provides all the flexibility and things that are great that we're talking about today. So it is just knowledge, really, that I think people have to pay attention to, and communication.
I can say that when you have the right group of people, starting from of course, the structural engineer, with knowledge in post-tensioning, a good general contractor, a good PT supplier, a good installer. Many a times, our repeat clients will come to our office, initial meetings, say, hey, see, let's go PT, we'll knock it out in 3 months. And that's what you want to hear, right? Because they know the system, they know our drawings, they know the way everything works, they have the right crew to install everything, and it really works very well for all parties.
All right, so I kind of want to work us towards the closure on this discussion, but one thing I wanted to touch back on that was kind of slightly mentioned earlier in that guide document that's coming out from DC 25, another element of that was studied, and it's really part of the whole industry, is the different framing systems within PT choices. And we've talked a lot about one-way beam and slab, which is really the kind of the gold standard as far as parking decks are concerned, whether they're standalone or mixed use or whatever they might be. And there's obviously major advantages with one-way beam and slab PT solutions, but also, of course, there's two-way slabs, two-way flat plate. Some people might come along and say, "Oh, I've got a smaller column grid. I've got a two-way system. What's happening? What's going on?" And we can, we've evaluated that closer as well to look at optimal ways to go about doing a two-way PT slab, and then also what I call a double prop cantilever. There's different terms people use where it's kind of a wide, shallow, banded type direction in a two-way system, and then you've got these column spans. They're more like on the back of the parking stall. So if you just imagine a typical bay, you might have a column 15 foot in and then 15 foot in on the other side, and you got cantilever slabs, and those can be very super thin and super shallow, and see a lot of that in residential projects and things like that. So in that guidance document, we've really studied, again, tied into what Mike talked about and others, one-way systems, two-way systems, the cantilever systems. And it's all about, no matter what structural challenge you have put before you, you can find a parking deck solution with PT that's very economical, very great with usage of materials and the efficiencies there, but also construction schedules. So I don't know if anyone wants to add to that a little bit, and then we'll kind of wrap things up in our overall discussion.
You're right. We probably should talk about framing systems. I mean, different framing options rather. And what architects like, what formwork contractors like, is having a flat deck, a flat soffit, because that reduces your forming costs tremendously. And so it's no surprise that across the US, the 8-inch slab on a 27 or a 30-foot bay is probably one of the most popular framing systems for a cast-in-place garage. There are other types of framing systems too, double cantilevers, or where you can go with either a 27-foot bay or a 36-foot bay, and another term used for that is a wide shallow system. So you can put the wide shallow beam in the direction of the driving direction of the garage, or the long direction of the garage, or across. And different engineers do it differently depending on the length of the cantilever and the edge load at the cantilever. If you have very heavy loads at the edge of the cantilever, like a full height CMU wall, then maybe you may want to put the wide shallow beam in the cross direction, or the 60-foot direction in the garage. But regardless, you can use two-way slabs for efficiency.
Yeah, and I think with the framing system discussion, the big thing with parking structures is columns and column locations, right? So, if you have a standalone parking structure, having columns out at the perimeter or at the inside ramps, giving yourself flexibility with the parking will maximize your number of parking spaces, will maximize your clearance and all that. But it makes it, it can make it efficient. But other framing systems, if you have a building, an office building, or a residential building on top of a parking structure, you're going to be more limited with where your columns can go, because you're not going to want to transfer them all out for a parking structure. So again, the PT just allows you that flexibility to pick the system that's going to work best for the what your end goal is, and it's going to keep the cost down. So Again, it goes back to flexibility there and just the different systems it can work with, which are all the ones that are talked about, you know.
Yeah, and I'll just add to that, Tom. I mean, there's some like secondary things that I think drive costs down too. I mean, from lighting, I know that was one of the things looking at that double cantilever, the amount of natural light that comes in on those because they're open, but also the flexibility for what you have on the outside. A lot of cast in place decks you can make look really nicely. They can fit whatever use you need, but you may not need to put up some type of siding, for lack of a better term, or EFIS or anything like that on the outside, because you can make the perimeter of a cast in place deck look pretty good for, pretty affordable, let's just say.
So I think that's great. I appreciate, again, everyone's time discussing this topic and all the different topics we covered from top to bottom, all relatable to, again, the overall cost effectiveness of PT parking structures from a design standpoint, construction standpoint, dispelling some of the myths that are out there about what PT is and is not doing in terms of the parking deck world. And so, again, this is a great kind of global discussion about all types of things, and I appreciate the panel's time. And so, again, stay tuned for further episodes in this series. We're going to talk further in the future about sustainability, long-term durability, and resilience. And so that's forthcoming in this series. So thanks for joining us, and we'll see you next time.
Thank you for joining us today. Be sure to visit our website at www.post-tensioning.org for more information and resources. Stay connected by following us on our social media channels to keep up with the latest updates and upcoming episodes. We look forward to seeing you next time.